All right, so additional topic number 1 is on modeling with equations. So modeling is not, shutting down a runway or anything. Modeling in math is like story problems. So some of you, it causes fear when I mention the word story problems. These are not going to be that bad. You guys can do them, I promise. All right, so it says guidelines for modeling with equations, so guidelines for story problems. Step 1, draw a picture if it's useful. Use appropriate variables and numbers to label the picture. So if you talk about area, use A, width, use W, length, use L. So use appropriate variables. Set up the equation using one variable. Solve for the variable. Is that what you're trying to find? All right, so in the first example, it says, in order to rent a U-Haul, you're required to pay a fee of $39.99 per day, and you pay 99 cents per mile. Okay, so let's suppose you're moving your things from Evansville to Bloomington. The total price when you moved was $173.64. How many miles separate the two cities? Okay, so we need to let x equal something. Or, oops, I forgot to orient. Hang on. Okay, what should x be? Yep. So we could even call it m for miles or x. It doesn't matter. So let's let x equal miles. And usually, for a lot of story problems, it will be at the very end. It's usually what it asks for. Sometimes it's easier if you don't make it what it asks for, and we'll do some examples like that. All right, so x is going to be the miles between the two cities. So we pay a flat fee of $39.99. So we're definitely paying that. Doesn't matter how many miles we go, we pay that each day. We're going to move our things in one day. I didn't say that. So we're moving them in one day. Evansville to Bloomington is not super far, right? It wouldn't take more than one day. All right, plus 99 cents per mile, so we need 0.99x, and that's going to equal 173.64. Okay, we solve it out. So do 173.64 minus 39.99. Divide by 0.99. Sarah, you want it over there? What'd you?
133.25.
Did you guys get that number? Oh, I thought it came out even. So okay, so 135. So 135 miles separate. Did you find any mistakes there? Okay, so that's the first one. So number 2 says the sum of 3 consecutive integers is 177. Find the 3 integers. Okay, hopefully you've done these back in the day in Algebra 1, but it's been a while. So usually when you have 3 consecutive integers, okay, these are numbers like 5, 6, 7. Numbers right next to each other. If it said consecutive odd integers, you need to do 5, 7, 9, right? Consecutive even, maybe like 4, 6, 8. All right, so if we have consecutive integers, we always let the first one be x. The next one ends up being x plus 1, right? It's one more than the first one. And the last one is x plus 2. Does that make sense? So this would be like x plus 1. This would be x plus 2. Because you start with x is 5, so that's 2 more. Okay, so that's what we're going to do to set up all of these problems. We're going to say let x equal the first integer. So that means x plus 1 is the second integer, and x plus 2 is the third integer. So it says the sum of these 3 integers. So I'm going to do x plus the next one, x plus 1, plus the last one, x plus 2, equals 177. So you get 3x plus 3 equals 177. Subtract the 3 over. So you get 174. Divide it out. So 3 goes into 17. 5 times 58. So you get 58 for your answer. All right, that is the first integer. Yeah, Sarah, do you have a question? No. Okay, so when it says find the three integers, that's the first one. So what's the next one? 59, and the last one's 60. So you have 58, 59, and 60. The only thing that's tricky about these problems, well, I guess there's two things. So one thing might be that it says find the sum of the even integers or find the sum of the odd integers. If you have that, the first one's x, the next one's x plus 2, because you have to skip over the number in between it, and the last one's x plus 4. The other tricky thing is sometimes they'll say, like, what is the last integer? So you'll solve for x, and then you're like, oh, wait, they asked for the last one. So you need to find all three, and then the last one's 60, right? So be careful. Always make sure you're finding what you're supposed to find. Some people like setting this one up with x as the middle integer. If you do that, then x minus 1 is the first one, and x plus 1 is the last one. And that just makes it a little bit easier to do with like mental math. Because you're basically just saying 3x equals 177. You find the middle one. So some people like doing that as well. Okay, next up. So now we have one with consecutive odd integers. So we're going to still let x equal the first integer. Now, a lot of people get confused on this, and they say x plus 1 and x plus 3 for the next ones, because 1 and 3 are odd numbers. But that's not actually what we want. X plus 1 would just be one more than our first integer. Does that make sense? So think about some odd numbers. If I had 5, 7, and 9, and this first one's my x, how much bigger is 7? 2, right? So x plus 2 is going to be the second integer. And then how much bigger is 9 than x? 4. You had 4. So x plus 4 is the third integer. So just because it says odd integers doesn't mean x plus 1, x plus 3, right? That's not what that's saying. It's saying it's 2 more than where you started. Okay, so we add them together. So the sum of the three integers, so x, x plus 2, x plus 4, equals 45. Find the three integers. So I have 3x plus 6 equals 45. So I get 3x equals 39. So x equals 13. Okay, that's your first one. So you have 13, 15, and 17. Those are the three consecutive odd integers. All right, try to draw the last one. So a picture frame is made to display an 8-inch by 10-inch photograph. The frame is a uniform width around the four edges. So we have a picture frame going around an 8 by 10-inch photograph. What does that mean, uniform width? Yeah, Carolyn, do you know? No, uniform? Yeah, it's the same width all the way around. I'm sure you've done lots of matting of artwork and stuff, yeah. So it's always the same all the way around. So maybe it's like 3 inches all the way around. Okay, so that means as I go around, I want it to all be the same width. It says the perimeter of the frame is 2.5 times the perimeter of the photograph. Okay, we need to somehow find what the width of the frame is. So notice how it says, what is the width of the frame? That's going to be our x, or we could call it w for width if you want. Let's call it w. Now that's the width going all the way around. So it's on all four sides. W is going to be the width of the frame. And you always want to do like a let statement so you know what that variable stands for. All right, if W is the width of the frame, originally we had 8 inches across, but now we have bigger than that. So what do we have? It's not 8 plus W. 8 plus 2W, right? Because you have a width on one side and a width on the second side, right? So you're adding in 2W. Okay, and then for our height, it was originally 10, but now I've added a width and a width. So 10 plus 2W. So we know the perimeter of frame It says is, so equals 2.5 times, so 2.5 times the perimeter of the photograph. So sometimes if you need to write it out in words, it helps. How do I find the perimeter of something? Yeah, add up all the sides, right? You don't just do like length times width, that's area. You do length plus width plus length plus width. So you add up all the sides. So for my frame, I would have 10 plus 2w plus 8 plus 2w. So those are two of the sides. You have another 10 plus 2w over here, and another 8 plus 2w up here. So you could put 2's in front of those. Like you could say 2 times, like that. Or you could just write it out again. It doesn't matter to me. So I'll go ahead and write it out. Okay, that's going to equal 2.5 times the perimeter of the photo. So the perimeter of the photo is 8 plus 10 plus 8 plus 10. Okay, so combine all your like terms. So on the left side I have 10, 8, 10, 8. So 10, 8, 10, 8. So 16 plus 16, or sorry, 18 plus 18 is 36. Plus, I have 2w, 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 2w. So 8w. The next one I have 2.5 times, I'm going to go ahead and add the parentheses. So that's the 8 plus 10 plus 8 plus 10 again, so 36. 2.5 times 30, is that 90? Will you guys check? Yeah, 90. Subtract 36 from both sides. And divide by 8. What do you guys get? 6.75. So that means that frame is really big. It's 6.75 inches. Have you ever seen like frames like that where it has a little bitty picture in the middle and a giant frame all the way around it? You're like, really? Huh. Okay, and then that's the width of the frame. The last thing says, what are the dimensions of the frame? So your dimensions, you just plug that number in for W. So if you had 8 plus 2 times 6.75, you get 8 plus 13.5. So you get 21.5 by, so you do 10 plus, that would be 13.5 again, so 23.5, and that's in inches. So you might be asked more than one thing. Okay, we good on that one? Okay, so go ahead and try to set this one up. So it says a pasture is twice as long as it is wide. Its area is 115,200 square feet. How wide is the pasture? What are the dimensions of the pasture? So try to draw a picture. I would probably use L and W since you have length and width, right? And try to figure out what those are. Come around and help. All right, so you guys all have the same kind of picture. So you guys have something like this. So it says twice as long as it is wide. So I'd make this the width. And you can call this L, but it's really 2W, right? Oh, you can't see it? Oh, it's not projecting. All right, so you have W and 2W. All right, so when you multiply those together, that's going to give you the area, right? Length times width is your area. Did it go? Okay, so you should have length times width. So W times 2W equals 115,200. So 115,200. So W times 2W is 2W squared. Get my calculator for this one. All right, divide by 2. so 57,600. And how do I solve for W? Square root, yep. So do square root of the answer. So what do you get? 240, you guys get that? Okay, so that's in feet. So it said how wide is the pasture, so we found that. What are the dimensions of the pasture? So the width is 240. Feet is just one little tick mark, so 240. Okay, and then the length has to be twice that, so multiply by 2 and you get 480. So those are the dimensions. Okay, and that's it. And we get it completely right? A couple of you. All right, so number 6. Matthew wishes to find the height of a 3-story building. He is 6 feet tall. He measures his shadow and finds it to be 3 feet long. The building's shadow at the same time of the day is 18 feet long. Find the height of the building. Okay, so basically, he's standing next to this building, and he is only 6 feet tall. So this is him. All right, and the sun's coming down, so the sun's up here. And it's coming down, and it's creating shadows. Oh, man. Thought I had that good. We're going to make him look a little taller. This creates what we call in geometry similar triangles. Do you guys remember similar triangles? Yeah. Mr. Cyric's in here. You better tell the truth here.
Similar because they have the same size. Same
Kind of.
angles. They have the
Same angles, yeah.
I remember.
All right, he's 6 feet tall. We want to know the height of the building, so you can call it B, H, whatever you want to call it. His shadow, so with the sun's rays coming down, his shadow is 18 feet. No, wait, his shadow is 3 feet long. The building's shadow is 18 feet long. Now, they don't have to be right next to each other. I mean, I could have drawn this like this for the building and him over here. The key to this problem is that this angle is the same. And so is this angle, the 90-degree angle, right? So they're similar by angle-angle similarity. Okay. So basically that the angles, or the sun's rays come down at the same angle. All right, so anyway. So we need to basically match things up. So I would do like height on the top and then shadow on the bottom for both of them. So in the first fraction, I'm going to talk about the building. So I'm going to say the height of the building is H, the length of its shadow is 18. And in the second fraction, I'm going to talk about Matthew. So I'm going to say the height of Matthew is 6, his shadow is 3. This one's really easy to do without cross-multiplying and in your head. Think about it. What's 6 over 3? 2. So you need H over 18 to be 2. So what's H? 36. Yep. Makes sense. Okay, so you just cross-multiply. You can cross-multiply, I guess. But 18 times 6. 108. So H equals 36. So the height of the building is 36 feet. Okay, next up. Maybe. All right, number 7. So 2 cyclists, 90 miles apart, start riding toward each other at the same time. One goes twice as fast as the other. If they meet 2 hours later, at what average speed is each cyclist traveling? I always hated these. They're not bad. All right, so the 2 cyclists are 90 miles apart. So I'm not going to try to draw a bike or anything. They start riding towards each other at the same time. One is going twice as fast as the other. We want to know the speed that each is traveling. So we can call that R for rate. You can call S for speed. It doesn't matter. My S's look like 5, so I'm going to use R. So let R equal the speed of, which one do I want to do? The speed of the slower one or the faster one? Okay, if I let it be the faster one, that means the other one is half r. So then we have story problems and fractions, and that's causing lots of fear in your hearts. So let's go with r as the speed of the slower. So that means 2r is the speed of the faster. Okay, so we're going to have r and we're going to have 2r. There's an equation we've used before that relates 90 miles to their speeds and their time that it takes them. What's my equation? Distance equals? Yep, exactly. Okay, you can do a chart sometimes on these. That's what a lot of people like to do. So we're going to have rate times time for each one, and that's going to be their distance. So we're going to talk about the slow one and the fast one. So the slow one's going at a speed of r, the fast one's going 2r. How long did both of them travel? 2 hours. So even though they met 2 hours later, it's not like one's going an hour and an hour, you know? Like they're both going 2 hours. So both of them are going to be 2. So our distance ends up being rate times time, so we're going to write it as 2r and 4r. So I just multiplied those together. So r times 2 equals 2r, 2r times 2 equals 4r. Sometimes that table helps people kind of get everything in their mind. One of the columns is one that you're figuring out based on the other 2 columns. All right, so what total distance did the 2 of them travel together? What'd you say? 90 miles, right? So 90 equals 2r plus 4r. So you get 6r equals 90. Divide by 6, so you get r is equal to 15. Think about the units. We went 90 miles. We were going in hours. Rate is miles per hour, right? So that one's going 15 miles per hour. The other guy's going 30 miles per hour. Just multiply by 2, right? I do want to show you one of these. Okay, so this is guidelines for solving a mixture problem. So hopefully you guys have seen these in Algebra 1. If you haven't, it's fine. Okay, so I always draw these the same way. So I set up a picture using jars. I put the percent of whatever I'm talking about inside the jar, and I put the amount below the jars. Then I combine the numbers into an equation. So this is Andrew wins $20,000 in the lottery and decides to invest it into 2 certificates of deposit. So one pays 7%, the other pays 3.5%. Okay, so basically you're going to have a certain amount and another certain amount of money, and we're going to get a total amount of money. So it says Andrew's total interest is $12.25. Okay, I have 7% for the first amount of money, and I have 3.5%, so 0.035 for the second one. So I put the percents inside the jars. Sometimes that helps to kind of see it. Okay, he won a total of $20,000, but we don't know how much he invested in each one. So we're going to let x equal amount invested at 7%. So that's going to be the amount that goes below. The other one, if I made $20,000 total and I invested $5,000 in the first one, how much did I invest in the second one? So if I have $20,000, I put $5,000 in the first one, how much do I have in the second one? $15,000, right? So the other one's going to be $20,000 minus x. That's going to be our amount invested at 3.5%. That's the amount that goes underneath here. Now, a lot of times we'll have a jar over here on this other side, but since I didn't say like what percent or anything that was, we're not going to do that part. So, oops, 20,000 minus X. Okay, so now what you need to think about, it's kind of confusing, but if I have $100, how much interest am I making if it's at a 7% rate? So if I have $100 and I go at a 7% rate, how much money did I make in interest? I already have the $100, I add on what amount? Do you guys do this with your bank at all? You get interest from your bank? You guys don't pay any attention to that? No. All right, so let's say shopping. So you guys smile on that. Okay, so I'm going shopping and I'm buying a shirt. Well, probably something more than a shirt because it's $100. Buying a $100 outfit. All right, and then I go to pay and they tell me that it's really 7% sales tax added. So if they add that sales tax, how much does a shirt actually cost? 107. Oh, we get the shopping reference. Okay, good. Does that make sense? You add on 7% of 100. Okay, so your amount that you're making in interest is what you get when you multiply these numbers together. So for the first bucket, you're making 0.07x. So whatever you invested, you're adding on 0.07. That's your amount of interest. The next one, multiply these. So you get 0.035 times 20,000 minus x. And the last one's still 1225. And now we solve. So I have 0.07x plus, so I do 0.035 times 20,000. So when I multiply those together, I get 700 minus 0.035x equals 1225. Combine my x's, so I have 0.07 minus 0.035. That actually ends up being 0.035 again. Subtract the 700, so you get 0.035x equals 525. So you get x equals 15,000. All right, the question is, how much is invested at each rate? You can just go back up to where you let your let statements, or where you had your let statements. See how it says amount invested at 7%? That's your x. So this is the 15,000. Circle it. So how much is invested at 5.5%, or 3.5%? 5,000, the rest of it. Right, so you can write it there, or you could write out. Andrew invested $15,000 at 7% and $5,000 at 3.5%. It doesn't matter. All right, these are going to get a little bit harder. We're going to finish them up next time. So.